Hi, my name is Ethan Bayard, and today I'm going to be talking about citrus batteries. And now I know what you're thinking, it's just citrus batteries, but today, wait a minute, something's not, oh yeah, there we go. Today I'm going to be talking about which sour fruits have more voltage. So how am I going to measure this voltage? Well, this is called a voltage meter. What it does is it has two tabs, and it will measure the amount of voltages coming out of whatever, like a battery or whatever. So let's get started with the lemon. So now the way this works is that, so you know how regular batteries, they have citric acid in them? Well, the copper and the zinc have a chemical reaction and they create energy. So on this one, I was getting an average of about 1.3 volts. Now, for a comparison, let me show you how it works, how it works on your house outlets. You get an average of 120 volts. Compare 120 to 1.3. Now, let's move on to the lime. On the lime, I was getting very close, but just barely under. I was getting 1.2, but it never ever spiked to 1.3. Never. So I thought that the lime was actually going to be more, but it's just not sour enough. So the copper and the zinc, I'll explain this in detail later in the video. The copper and the zinc, they combine with the citric acid just like they do in the battery. So here we go with the orange. I was expecting way below because they're very sweet, but they're also sour. And with the perfect balance, you can barely tell. And I was getting an average of 1.1 between 1.1. So just barely below. These are all very close together. And just for funsies, we can try a motor, just a little motor. And one thing I didn't notice was that I was using a 12-volt motor, and I couldn't find anything smaller than 12 volts. So I was kind of surprised because I was not getting anything out of the motor because it is, however, 1.3 to just 1. It's just 1 to 12. It's just not enough power. So yeah, you're going to need a smaller motor. So let's go to the graphing. So here's a graph that I made in slides. And you can see the lemon has 1.3 to 1.2. The lime has 1.2 to 1.1. And the orange has 1.0 to 0.9. So as you know, with most science projects, I have to know what I'm talking about. So here I go explaining how it all works. So here we can see the copper on this side and the zinc on the other side. Both are combining to create power or electricity. And this is the copper produces the positive side and the zinc produces the negative side. And I guess another way of putting it is think of the lemon as a single or just like a cell of a battery, and the zinc in the nail and the zinc in the nail and then the copper wire or penny are called electrodes, and the lemon juice is called an electrolyte, which is like the energy from a cell, I guess, or acid energy. And all batteries have a positive and negative terminal. Electric current is a flow of atomic particles called electron. Certain materials called conductors allow electrons to flow through them. Most metals, copper or iron, are good conductors of electricity, and electrons will flow through the electrode of the battery through the conductor towards the positive electrode of a battery. Volts or voltage is a measure of the force of moving the electrons. So that's all I have for you guys today, and as always, thanks for watching.